Hello friends, this is the section of application of derivatives, and in that we have several types. The first type is what is the geometrical meaning of derivatives. Now in schools we have learned how to plot a straight line. A straight line. The equation of straight line, for example, if it is y is equal to x, means function of x is x, y is equal to function of this is x. So if I make a table, if you recall you have done this in your school days, if I make a table, I take value of x, then y is equal to function of x. So if I take x 0, the y will be f of x is equal to 0, so y also will be 0. If I take this one, this will be 1. If I take this 2, this will be 2. If I take it minus 1, this will be also minus 1. And so with these points, now let us make one more row for the point x and y. So the point first will be 0 0, this will be 1 1 because y is equal to x is the equation, and this will be 2 2. Similarly any value minus 1 minus 1. So if I plot the graph for this equation, this function, I take values here, and if I plot the graph, it will be like this. This is 1 1, the first point. This is 1, this is 1, it is 2 2, the second point, 3 3, the third point, and so on. Similarly you can plot the graph of any straight line. So if we take y is equal to 2x plus 3, or any equation y is equal to 3x minus 5, and so on, we get the straight lines of different slope, different intersections, and all these things. What I want to stress here is when the function of x contains the power is equal to 1, then it gives rises to a straight line. This is what I want to stress. And if the y is equal to x square, if suppose this is a function, now if we similarly plot it with table, and the graph will look like this. It will be like this. Because it is x square, if we take 1, it will be 1. If we take 2, it will be 4. If I take 3, it will be 9. But similarly, if I take minus 1, it will be plus 1. If I take minus 2, it will be plus 4. If I take minus 3, it will be plus 9, because square is always positive. So these are the values. For minus 1 it is 1, for minus 2 it is 4, for minus 3 it is 9, and same for plus 3, plus 3, plus 2, plus 1. Here it is 1 2 3 plus, here it is minus 1 minus 2 minus 3, and this is 1, this is 4, this is 9, and so on. If we take 4, it will be 16. Minus 4 also gives rise to 16. So what I want to make your attention is when the function has, if power of x is 1, it gives rises to straight line. And if power of x is greater than 1, anything, let it be 2 3, it gives rises to a curve. Now there is a very nice website. This is website, it is desmos.com. the website name is www.desmos.com. it is very nice tool you can try out. Let me demonstrate you what we have done in previous things. I will write here function y is equal to 3x plus 7. It shows the graph here. Here is the graph. Y is equal to 3x plus 7. So you can put any number of equation. The y is equal to x. See, it passes through the origin. Let's see, this is 5, 5. It is 10, 10. Similarly, minus 5, minus 5, and so on. You can zoom and see the details values also. Say this is 1, 1, 2, 2. Okay. Similarly, you can put any equation there. Y is equal to x minus 4. This is the equation. The black line is y is equal to x minus 4. You can try out this. Now what I want to stress you, that when the equation has power of x more than 1, say it is x raised to 2, then it gives rise to a curve. See what I have demonstrated this. If you zoom it, see the values. See 1, 1. For 2 the value will be 4, and similarly see, I can check all these values. The curve goes to infinity. Similarly, if you put y is equal to x cube, see here is the green curve. It is like this. It passes through origin, and so similarly, y is equal to 2x square minus 7. See, it is shifted down to minus 7. It is 0 minus 7. 2x square minus 7. This is the curve. So the point is very clear, that if the power of x is 1, it gives rise to a straight line. If the power of x is greater than 1, it gives rises to curve. This is the first step in knowing the geometrical meaning of derivative. Now let us go to what exactly the derivative means. Simply, derivatives means slope. Now let us see what exactly the slope is. What is slope of a straight line, what is slope of a curve, and all these points. Now first thing, let us see what the slope means. This is a straight line, for example, we have taken. Now this is a point, this is another point. These are the x coordinates and y coordinates. This is a, this is a plus h. For example, the distance we have increased by h, so it will be function of x, so it will be function of a, whatever function it may be, and this will be function of a plus h. So this is change in y, and this is change in x. So by definition, slope is defined, you learn in school, it is change in y divided by change in x. The ratio is called slope. So it will be dy by dx. So it will be, dy will be function of a plus h minus function of a, and in the denominator it will be a plus h minus a, or simply it will be function of a plus h minus function of a upon h. This difference is h. This is the geometrical meaning of derivatives. So now recall the previous example, that y is equal to x. Y is equal to x. So in this example, if we want to find the slope, now let us find slope. By definition, and slope by derivatives. Here y is equal to x, so if we assume this is 3, this is 4, so this also will be 3, this also will be 4, so change in y will be 4 minus 3, change in x also 4 minus 3, so slope of the equation, that straight line, is 1. Now find the slope by derivatives. Now y is equal to x, function of x, so differentiate with respect to x, it will be dy by dx, the derivative of x is also 1. So finding slope is nothing but the finding derivative of that equation with respect to the variable whose it is function. So it is very simple. Now let us move further to the concept of slope of a curve. Now we have learned that slope of straight line. Let us find some more slopes of straight lines so you that get clear idea. Y is equal to 3x plus 5, so dy by dx will be 3 into derivative of x is 1 plus derivative of phi is 0, so dy by dx is equal to 3. Again y is equal to 4x minus 8, dy by dx, the slope of that straight line, 4 into 1 minus 0, slope is 4. Now here you have observed that here also the slope of straight line is a constant number. This is a constant number, this is a constant number, this is a constant number. So we have come to a nice conclusion that slope of straight line is constant. Means the slope of straight line doesn't changes, it is constant all over the straight line. But what about the curve? The slope of curve. Since the inclination of the curve goes on changing, so let me draw a curve here. So for example, this is a curve. Now its slope is different at different points, you can easily observe. If you want to take slope at here, you will have to draw a tangent at that point, and this will be the slope of that tangent, that will be the slope of curve at that point. But if you change the point, the slope changes. If you come at here, it is horizontal line at the top. So the slope of curve is not constant. This is very important concept. Why it is not constant? Simply see, this is y is equal to x square. So if I want to find slope dy by dx, it will be 2x. Now it contains the variable x, which means that the slope will change with the value of x. So it is not constant at all points, it changes with the value of x. Similarly for any curve, because every curve will have the power of x more than 1, its slope will be changing. So we have learned two rules. The first one, the power of x in straight line equation is always 1. That's why it shows a straight line. And second thing about straight line, we have learned the slope, that is dy by dx, the rate of change of y with respect to x is constant in straight line, is constant for straight line. And second concept, very important, we have learned the power of x in equation of curve is more than 1. Hence if the power is 2, 3, it is a curve, and the slope of curve is different at different points. This is very important concept. Different points. Now next question is how to find slope of curve. Slope of curve at given point, because it is not constant all over the curve, so the point must be given. So we have given y is equal to function of x, and to find slope at x1 y1 for example. So simply what we will do, we will find derivative dy by dx of this given function, whatever it may be, f of x, and then find dy by dx at that given point x1 y1. Means we put the value of x and y in this equation. We mostly need to put just x, and whatever the value comes, this is the slope. This is the slope of that equation at that point. So actually this is the slope of tangent, we can say, to curve at that point, at given point. That is dy by dx at x1 y1. And we can also find the inclination of that tangent. Inclination of tangent, that we know, we learn in the schools, that inclination, the tan of inclination tan theta is equal to dy by dx at x1 y1, or tan theta is equal to simply the slope. Okay, so we will use this all understanding to solve these problems. So summarizingly, an equation which contains x, power of x is 1, is equation of straight line. An equation which contains power of x2 is a curve. We can find the slope of straight line. It comes out to be a constant number, because the slope of straight line doesn't changes with points, whereas the slope of curve is not constant at all points. It changes from point to point, and the slope of curve at a particular point can be found by finding the slope of tangent to the curve at that point, and it is found by finding the derivative and putting the given point in that curve. Okay, as we see on the examples of these types, you will get clear idea. Okay, thanks for watching.